Hi, this is Owen Beyer, and I'm looking forward to being with you next week at MathPath. This will be my ninth or 10th year at MathPath. It's always one of my favorite weeks or 2 weeks of the year. The course I'm going to talk about in this show and tell is inversions. This is a geometry course. I've taught it many times at MathPath, and it's, I think, a lot of fun. I wrote a geometry textbook, and this is a chapter in that book, so a lot of what we do will be based on what's in that chapter in terms of homework exercises and example problems and so on. So think of an inversion as just a transformation of the plane. It moves all the points around in different ways. You could also do it in 3-space, not just in the plane. And let me show you a picture here. You can see the square that has a young woman in there, and then it's reflected across the circle. So an inversion is just a reflection across the circle, like usually you think of reflecting across a line. So there's different properties when you reflect across the circle. So you can still tell that it's a woman. She's facing the other direction. The top edge of the square got moved into what looks like part of an arc of a circle, and there's some other properties there which we will explore with inversions. We will see how to actually construct an inversion using geometric tools. We will use the software GeoGebra throughout the course, which is available online, very similar to Sketchpad, which you may have used in the past. Our main goal with inversions in this course will be to prove theorems in geometry. I have an example of a theorem here called Steiner's porism. We will prove this result. We'll also see how, maybe if time allows, how to use inversions to create a picture like this one. Anyway, for this theorem, circles C and D are the same in each figure on the left and the right. C is inside of D. And then on the left, I put in circle C1. I inscribed it to be tangent to both C and D, and then put C2 in there to be tangent to C1. You can see it here, all the way around the circle. And it turned out that there were exactly 10. The last one came and fit perfectly. And the theorem says that no matter where you put that first circle, if you can get them to go around and be tangent in one instance, no matter where you put the first circle, it would be the same in the other one. It's quite a remarkable theorem. So on the right-hand side, notice that circle D1 is a little bit lower than what C1 was, but when I started to inscribe the tangent circles, came all the way around and exactly fit. And this is very easy to prove with inversions, and that will be one of our main examples. And we have some other classical results we'll be proving too. So if you like geometry, like to see beautiful results using circles, there will be a lot of that in this course. Hopefully see you next week.